in the future, if you have any kind of question, please post it on the forum unless it's not a personal question. For that kind of situation, you can use the BFMC email. Okay, then I will share my screen. Can you see my screen?
Yes, we can.
Yes,
Great,
we can.
great. Perfect. Then we will start with the documentation. So Raresh already showed you last week. Here is our documentation. I will jump directly to the embedded platform. Inside our embedded platform, we have the preliminary setup, building and flashing steps, then explanation about the new component script, debugging, main flow, and also we'll talk more about the calibration. Then let's start with a short overview about the embedded platform. So the embedded platform runs on the Nucleo F401RM microcontroller. It acts as a bridge between high-level processing and low-level motors and sensor reading. Basically, she is responsible for your car control. Then the components inside the embedded platform are structured in 4 main layers. We have a brain layer, drivers, periodics, and utils. Inside the brain, there is the state machine of the Nucleo, KL manager and power safety features, global state definition, high-level controlling logics. Inside the drivers, we put the battery manager, the IMU sensor, steering motor, speeding motor, the serial communication, the VSD. And for the periodics, there are a lot of components that run on a specific time with a specific frequency. And for the utils are the task manager, so on. Then starting with the preliminary setup. Just a second. Okay, so can continue. So everyone can hear me?
Yes, we can.
Okay.
We can.
I will continue. Then let's start with the preliminary setup. So you need to have Python installed on your setup. Make sure you use a version newer than 3.6, or maybe if you want, especially 3.6. I checked all the links, should work. You have to install the CMake. This is responsible for the building process of your software. You need to have Ninja installed, the Embed Tools kit, a cross compiler, the pretty table interhex. This is the library that is showing you how much RAM are you using, how much memory is allocated, how much is not. Then for this cross compiler to work, and also Python, you have to do some Windows setup. I think it's pretty similar in case of for Mac developers. You have to set your Python path and also the ARM embedded toolchain path. I already put some commands over here, just copy paste it, and also make sure you replace that field with your user with your actually Windows username. Then after you pull your embedded repository, go inside your working directory and use the command embed tools deploy. You have to wait sometimes until it gets done. Then jumping to the building and flashing. The building process is pretty straightforward. It's just a command. You have to, the command is embed tools, -tools, compile, -m. The name of the Nucleo is the target. But we'll take it step by step, and I will show an actual building process for you. Then after the building, yeah, in this case, it showed no work to do, but in your case, will appear a table with the memory used. Now, more about the flashing, it's pretty straightforward. You have to go to the bin files and just drag and drop the files on your embedded platform. But again, we will do it in a live hands-on. Now, more about the new component. What is this new component script? It's a Python script that helps you to create a new component, any kind of component. Maybe you want a new component that reads a sensor every 1 second. You don't have to investigate all the Git repository to understand how can you do it. Just use this script. You have to answer some questions in this script, and the script will create the component for you and already implemented. Then more about the debugging. So for the debugging, I recommend you to use the PuTTY. It's pretty good. I personally use PuTTY, and also if you like, you can use Term. They are pretty much the same, only the UI UX is a little bit different. But for the PuTTY, you have to set your communication type as serial, the speed baud rate, force on, so you can be able to type inside your PuTTY. But again, we will do it in a live, hands-on, and also wait until you see the I am alive message. Now, we have three actually power states. So we implemented 3 KL values, all designed as safety features. So when the KL is set to 0, nothing is working. Whatever command you send or ask from the Nucleo, it will be discarded. Let's say if you want only your sensors to work, maybe you want to see the IMU data and reading other sensors data, and you don't want to take the risk to set the speed by mistake, you have to set the KL value to 15. And also, if you want to enable everything on your car, use the KL value. Also keep in mind that the steering and the speeding motor are working only when the KL value is set to 13. Now, more about the power manager and also about your buzzer. So as already you saw, every car has a buzzer. We have 3 different types of sounds for each value of the KL. And also we have a warning sound when your battery drops below 7.2 volts. I can assure you that it's a pretty annoying sound. So make sure stop everything you do and charge your battery and then go back to work. And if your battery drops below 7.0 volts, pay attention because there will be sent an error message with the text shut down, and everything will be shut down, Raspberry Pi included. So to make sure that none of your work got discarded, don't wait until the power manager shut down your system. Now, here is a very detailed explanation about every component we have, every commands we have on our embedded platform. So we have a command for speeding, steering, braking. You can enable or disable your battery level, instant consumption, IMU data, control moved. This control moved, you can set for a specific period of time the speeding value and the steering. And after that, it will stop the KL. But don't worry, Also, this part, we will take every command and we will use it in our live hands-on. Also, every time you send commands, you will receive a response. The response will contain the component name, followed by the value. In case of battery level, you send hashtag battery1 to activate the component, and she will respond to you with the battery level. Now, some limits. The Nucleo has a few limits as follows. The maximum speed allowed is 500 millimeters per second. The maximum steering angle is 25 degrees, but also can be modified according to your calibration. The maximum time for control movement is 25.6 seconds, and the maximum frequency for the IMU is 150 milliseconds. Okay, also we can go with the main flow, and here is everything we have inside our embedded platform. So I don't know why I can zoom out to see it. Oh, okay, that's great. So basically, this is how we structure the code. So everything is included on another component. So we can start with the KL manager. So the KL manager is not actually the boss, is the vice president of the embedded platform, because without KL manager we can do anything. So as I told you, the KL manager is able to control all the component, the speeding, the install consumption, battery, and so on. But the KL manager is also controlled by the power manager. And to be more specific, you are not able. What's going on when you start your system, especially your Nucleo? The power manager starts instantly and will start measure your battery level, your instant consumption, and he will decide if you have enough juice to run the system. And if the answer is not, we'll shut down everything. Also, if you want to know why your Nucleo board is not responding to you or what's going on, also check the green LED that is on your Nucleo board. If it's not blinking, your Nucleo board was shut down due to low battery level. Now, I think it's better to go inside the code. Okay. And let's start with the main file. Yeah. What do we have here? Yes, we have a dummy value, and also the first global variable we have a G-base tick. What is this G-base tick? Is the base sample time for the task manager. The measurement unit of base sample is milliseconds. And what is this task manager? We will dive into the task manager in a few moments. So this system runs every 1 milliseconds in the back. Now we have an unbuffered serial variable. This variable is responsible for the serial communication between the Nucleo board and the Raspberry Pi. Here we have, I think it's a funny workaround. Why I put this dummy variable here? Because I saw that when Raspberry Pi is starting up, he is sending some signals on the serial communication, during his boot, and especially that signals are interpreted by shutdown signal or reset signal for the Nucleo board. And for this situation, I put a component that waits, I think it's 10 seconds wait. So in the beginning, you will see just booting up, wait for I'm alive. If you want to delete this, be my guest, but if you delete these lines, your servo motor will start acting unnormal, will start rotating sometimes, only sometimes, to the maximum value to the left or maybe to the right, depends on the signal that are sent into the Nucleo board at the startup. But just leave it here and you are safe. Then we have the blinker component. This blinker is responsible for that green LED that I told you. Now, all the components that are periodics should have a period of time. And how can we interpret this period of time? So we have the G-base tick that it's equal to 1 milliseconds. So multiply by 500. We know that this component is called every half a second. The alerts are called every 5 seconds. Also, the alerts is the component responsible for your buzzer. Yes, if you want, you can add newtons, but please go inside. We have to go inside the component to show it to you how we have to structure the code, because as maybe you already know, when you are working with the buzzer, you have to put some sleeps, but it's not recommended to put some sleeps inside the embedded platform because it will slow down your entire code. Then we have the instant consumption component. This component is called every 1 second, is reading the data from the analog pin number 2, and we pass the unbuffered serial variable to this component. So in this manner, she is able to communicate with the Raspberry Pi via serial. Then we have the total voltage component. This component is called every 3 seconds, is reading the data from the A4 pin, analog pin number 4, and is sending the data via serial to the Raspberry. Also, we have the IMU, the CIMU. This component is responsible for reading the data from your IMU sensors. This component is called every 150 seconds. It's sending the data via serial to the Raspberry, and it's using the I2C protocol to get the data. Then we have the serial and the speeding components. You have to use this component to control your steering and your speeding motor. The digital pin number 3 is used for speeding, and digital pin number 4 is used for steering. Then we have the robot state machine. This component, it's called every 1 milliseconds because this component is responsible for the robot state machine. So this component decide in what state is your component right now. We are speeding, we are steering, we are braking. So she had to have she should have a very instant response. Again, she can communicate with the Raspberry Pi via serial and also have control above the steering and the speeding component. We have a resource monitor. this component, it tells you, it's called every 5 seconds, of course, and it tells you via serial how much heap and how much stack memory you are using in that moment. Also, the KL manager. This KL manager is in charge for the alerts component, IMU, instant consumption, total voltage, robot state machine, and resource monitor. Because he decides if you can use the alerts, the IMU, and so on. And also the power manager. The power manager is called every 100 milliseconds and also have control over the KL manager, so over everything. He is able to communicate with you via serials, just for telling you that, hey, you have 5 minutes left from your battery, and also is able to read the total voltage, the instant consumption, and to play a sound at the buzzer. Now, the battery manager, this component is responsible if you want also to use another battery that has another amps value. I don't know, our battery has 6 amps value, but some of you maybe got the 5.5 amps value. Maybe you want a bigger battery. You just have to call the component and tell the component, hey, I have a bigger battery, here is my value. Now, we have monitor subscribers. Here you have to put all your components that have a serial callback. So as I told you in the documentation, all the commands are put here. Only in this manner you can use the hashtag and the name of the component to control your component. So in this case, what is going behind? So let's say every time you type and you send the hashtag speed, will call back a very methods from robot state machine, the serial callback speed command. We have the serial monitor. The serial monitor is responsible for all the commands and also the task list. Now, all the components that are a periodics component should be included here with the reference. Why? Because because this list will be passed to the task manager. And now let's dive into the task manager. What is this task manager? Let's go to the implementation. Let me find it. Here we go, task manager. So when we create this component, so we have to pass him the task list and also the task count. Yeah, will be already passed. And what he is doing? He will be called every 1 milliseconds and will call all the timer callback method. So all the components that are periodics are a child of the utils class. To be more specific, all the periodics component has a variable member called ticks. What is this ticks? So as I told you, let's get an example. Let's say the power manager. Yeah, so we have 100 ticks for the power manager. And what's going on over there? So this task manager calls every 1 milliseconds all the component. So after 100 milliseconds, the power manager will have 100 ticks. And then also the task manager calls every run method for every periodic component. And the run method is called only when we reach the ticks threshold. So in this way, we have a simple way of integrating the task manager. This is why we use this GPS tick multiplied by a number. So every time you reach the GPS tick, we call the run method. And yeah, here is your main. But I told you about the new component script. So okay, but maybe before that, let me check the chat. Let's see. Oh, you're pretty active. Okay, so the report, I think, Rash already responded. I have a question regarding the exporting the calibration file in the last step of this link. I have the visualization plot, but when I click on save and downloading, nothing is exporting. Does anyone? Okay, that's interesting. We will do a live calibration. So maybe I lucky enough to have the same problem as you all, and we will solve it. It's mandatory not sending. Yeah, as I told you, Radish is the bad guy, I'm the good guy. Rad will cover it. Okay. Yes, just you check your audio. There is no sound for me. It's only you. Has nuclear Wi-Fi? No, it doesn't. Feel free to step into the stop. If something is unclear, or this question, I prefer at first. No. Okay, let's calm down a little bit. This version doesn't. Yeah, that's right. Also, if you want to use a version of Nucleo that has Wi-Fi, be our guest. Yeah. Okay. Is it possible to have debug connection to Nucleo at the same time when it's connected to Raspberry Pi? No, you can do it because you have the same linker for the word. Maybe, or let's check. There is a possibility only if this kind of Nucleo has multiple words on different timers. So let's see. So this is word 2. Okay, on the timer pulse width modulation 2. Okay. Word 1, the X, word 1 RX on timer number 1. Okay, so I see that there are 3 different word ports, but no, only 2, sorry. We have to look for RX, TRX, receiver transmitter. Yeah, I think it's possible, but make sure you don't use the same word communication as the USB is using, but I think it's a try and error process. Try all the word ports, and I think here it is. So the USB vbus is on wart 1, timer number 1. So yeah, don't use the first wart, and also don't use the timer 1. So let's see. Yeah, try on these pins. There is a different wart, and I think also it's a different timer. So yeah, I think you can do it. Yeah. If doesn't contain Wi-Fi, also use. I don't know. I think. Okay. I have one doubt for report. One manual control is enough or autonomous needed? Well, the manual control is already did by us. So you have to show us what have you done until then, something new. Should I use project that BFMC provided or write firmware myself? Well, if you want to write the entire firmware by yourself, yes, you can do it, but I think you can save a lot of time by using our firmware. Port, not the estimates, links stay connected for PC debugging. Yeah. Okay. And should I use one MCU and actors for many sensors, or use each MCU for each sensors and communicate via CAN? Oh. I think both way can work. For each, no, I think it's enough to use just one microcontroller. You don't have to buy like microcontrollers for each sensor. I don't see the reason to buy multiple microcontrollers. And also don't forget to post all your car modification on the forum. Okay, then if I will come back to the chat after we create some new components. So let's create a new component. So right click on the new component, opening integrated terminal. Okay, and let's start the script. Python new component 5. Okay, now let's create a periodics component in the beginning. Let's create a periodics. The name of the component, let's say periodics test. Why not? Okay. Do you want a serial callback command for this component so you can interact with her like this? Yes. Let's have one. Then we have a summary. So we'll create inside the periodics category, we'll create the periodics test component with a serial callback functionality. Yes. Then, as you see, the script created two files, the header file and the implementation file. And also is not noted here, but all the components that you will created will be also included in your header file of your main. Let me see here. So down below, as you see, we have already included the periodic test header file. Now, as we told the script that is a periodic, let's check the main again. So right here, we can see that we have a new component. It's inside the periodics namespace called, it's a type of C periodics test called G test periodics. And the script will leave your component like this, your periodic component like this. So it's a gbase t multiplied by number of milliseconds. And let's say every 1 second, so it is 1000. And also because she's a periodics component was included here in the task list, because as I told you, the task manager will increase her ticks every 1 milliseconds until is reaching the threshold. So yeah, and also the script already created the callback for you, so the periodics test. So every time you type inside the serial hashtag periodics test, the embedded platform will call the serial callback periodics test command from the gperiodics test class. Now let's check the files, the new files. So yeah, the script already do the inheritance process. So as I told you, all the periodics components are a child of the utils task manager class. Is already defined the periodics, and I think here is a mistake. I don't know why, but we will solve it together. So yeah, it's already created the one private method member, the run method, and a flag that is telling you that the component is active or not. So this component will become active only after you reach the ticks threshold. Now let's go to the implementation file. Yeah, so we have no behavior for the serial callbacks command, and also here is your run method. So yeah, this method is called very frequent. So it's passing this line only if your component is active. Now let's do a build. So yeah, so let's navigate to the to our working directory. In my case is in documents, embedded platform. You have to go inside the cmake build directory. Also make sure you go inside. Maybe some of you will have multiple targets over here if you are using multiple kinds of Nucleo board. In my case will be this one. Develop, this is ARM, okay, and here is your bin file. Now, before this, here is your bin file, but this file, before we can use it, we have to build our new code. So again, let's go to our embedded platform directory. We can type over here, type cmd, or if you want, you can navigate directly. Embed, tools, compile, -m, typing the target, and our target is Nucleo F0401RA. And the tool chain that we are going to use is GCC ARM. Now, the embed tools will start compiling our code. And maybe if I'm lucky enough, without any errors. Okay. Okay, so as I told you, here is a success message. You can interpret it as a success message because the embed tools build the code, and the build is located in username, documents, embedded platform, CMake build, target, and robot car bin file. And as I told you, this tool is showing us how much RAM memory and how much flash memory we are using. Then, now that we have our build, let's go inside this path. So let's check it again. So it's inside CMake build, target, develop, toolchain, and robot car. Make, target, develop. This is the ARM, and here is our bin file. Now, what we have to do is to copy this file. So we can copy and paste it inside our Nucleo board, but let's use the drag and drop method. So okay, so let me connect the USB to my computer. Is connected. Let's open a new Windows Explorer. Okay, so go to, so after you connected your Nucleo board to your computer, go to this PC, and here you can see your Nucleo board. Yeah, it's a D partition, should be a D partition. Double click inside, and you can see here we have an embed.html, some details, and just drag, hold, and drop on your board, and it's done. Yeah, so the second the Windows Explorer will disappear after the code was flashed to your Nucleo. And yes, so let's use Putty now. As I showed you in the documentation, you can use Putty. Let's do a session. So check the COM port that Nucleo is using. So search for device manager and go to the ports, COM and LPT. And we can see that SMT microcontroller ST-Link virtual is using the COM port number 4. So inside our PuTTY, we will type COM 4. The speed is 150 to 100. And also we have to go to the terminal, type force on, and go back to session. And to be easy for you, don't press open, not now. Type a name here, let's say 2025 test, and hit save. So every time you open this session, select the name, load, and all the configuration is already done. It open. Yeah, maybe also check that the cable is connected, is well connected. Okay, let me open it again. load, open. Okay, that's weird. Or maybe I can use the other device. Let's use the Terraform. Okay, COM4. Yeah. Okay. So in my case, for some reason, the put is not working, but the Terraform is working. But you should not have any problem. But if you have any kind of problem with the putty, post it on the forum, and I will help you debug it. Oh, maybe let's try again. Maybe to understand why. Have you tried to connect to your Nucleo board before using putty? Did you face any kind of problem? There are a lot of problems when we using putty. Okay, that's a start. And have you tried the Terraterm terminal? Okay, so let's do it again. So let's see. So we have the COM number 4, 150, 200, terminal, force on, open. Okay, so now it's connected to the COM4. Yeah, so booting up, wait for I am alive. Yeah, it's the first time when I see this, I face this kind of problem. Okay, I'm alive. I'm alive. Now let's try to speed up the car. Should work, right? Oh, no, should not work because we didn't have set the kill value. Exactly. Yeah, look who is paying attention. Okay, so Actually, you know what? I will modify the documentation. Let's use TerraTerm for this session. It's well too annoying. Well, okay, let's restart the board. Let's wait a little bit. And let's do the setup. I am alive. So again, let's do it again. Let's set the speed to, oh, not try bad spelling. Yeah, speed. HL30 is required. So let's try the steer. Maybe the steer is working. Oh no, it's too high. We are above the limit. No, it's not working. So we have to set the KL value to 13. Exactly. So the steering and the speeding are working only with the KL 13. Or maybe let's try to start the IMU data acquisition. I'm sure that this is working. No, not really. Or maybe we can check the battery level. What do you think? No. Then let's do it properly. Let's set the KL value to 15. I hope you heard it. There is a specific sound for KL 15. So yeah, all you have to type the KL with lowercase. Don't try with uppercase, will not work. And here you can see we have a lot of data from the IMU, some data from battery. We have a very low instant consumption level. And maybe let's stop the IMU. And don't worry if you are not seeing in the real time what you are typing. There will be no error. So type hashtag IMU _0, control me from monkey as I am, G from Joker as I am. Then the IMU has stopped. Now let's stop also the resource monitor has stopped. Let's stop the instant consumption, and the battery, because I want to start it one by one. Okay, so nothing is up right now. Let's start the battery. So we type hashtag battery $1 to activate, control M from monkey, G from Joker. And as you can see, we have a response with, I don't know the name of that symbol, battery 1. So we can see that we have 8 volts over here in our battery, so it's fully charged. We can stay here all the night. Now let's activate the instant consumption. Instant $1, control G. And we are using 65, 70, 57 milliamps per hour. So we are using nothing, almost nothing. Then let's stop everything. This is the stop. And then let's open the, let's set the kill value to 30 so we can use the steering and the speeding. Okay, so everything is working right now. Let's stop the IMU so we can see something over here. Let's stop the resource monitor. Battery. The instant. Great. Now, let's set now the speeding value. Let's go full force. Okay, so as you can see, you type hashtag speed the value and you will have a response. Then let's set the steering. No, bad spelling. Okay. We set the steer value to 50 degrees. Yeah, all the values that you are working with inside the embedded platform are in integer. So in this case, we are using 150 for 50 degrees because it's more efficient to use only integer numbers instead of floating numbers. You will have an instant feedback if you are using integer numbers. Let's set the steering back to 0. And also there we have a few commands, the velocity control duration command. So you can set the, so type hashtag VCD, double dot, the speeding value, 150, and the steering value 10 degrees for the next 2 seconds, let's say 20. Yeah. Comma, Control me, Control G. Now, yeah, the car will set the steer and the speed for 2 seconds at those values. And then when it's done, you will have another message telling you that, hey, I'm done. I'm setting the time to 0, the speeding to 0, and the steering back to 0. But let's see if we can use our new component. Let's see. So we know that our component is called periodics test. So we can type this here, hashtag periodic test on, and nothing is happening because we have to do some work over here. So this is, I want to do it in this way for you to see that it's easy to implement everything over here. So we want the component to be able to communicate via serial with us. So what do we have to do to pass the gRPI component? Just paste it here. Then let's go back to the header file. So we have to include the serial part in our constructor. And don't worry, in my humble opinion, it's way more efficient to do it in this way. Go to another component that you are seeing here, that she is using the serial communication. Let's say the resource monitor. So yeah, it's inside periodics, resource monitor. Let's find it. Periodics, resource monitor. No, the header file here. And we can see that, oh, okay, so we have the period and we have to put a new parameter, a new argument, sorry, and paste it over here. And so just copy and paste from another component to create a new one. Let's copy the unbuffer auxiliary private member and paste it, I don't know, here. Why not? Then let's go to the implementation file. It is. We have the implementation file, and we can repeat this process from here. Let's go to the resource monitor implementation file. Let's see. What do you have here? So we have to include the unbuffered serial. Just copy it, paste it, and also let's copy the initialization, copy this one, paste it here, and it's done. Not really. So we have here, we have a message, a response. So let's see, how can we do something here? So let's use this one. Let's use the sprintf method. Let's paste it here, and let's say that inside the response, put the text hello from periodic test. Exactly. That's perfect. And now, and also, let's say that every time this component is called, we want to activate her. Let's copy the behavior from here. So in the beginning, will be 0. Yeah. Yeah. Why not? Here it is. The Copilot did all the work as usual. Yeah, sure. Else. Now let's see. Is he smart enough to do something like this? Let's say we have a buffer, and we want to do this. Yeah, exactly. Okay. Now our component is pretty done. Yeah, so don't worry. You can use any kind of LLM do you want. It's not forbidden. Now let's build the code. Yeah, so let's use the command again and let the embed tools compile the code. Good. Until the building is done. Yeah, perfectly. Why not? Let's have an error over here. Oh my. What have we done? Oh yeah. Who worked here? Because it's not in this way. You're not in Java. Okay, let's build it again. Let's check the chat. Can you repeat what needs to be done for the first? Yeah, anything you consider to be enough as your team planning. Maybe you can create a new embedded component and you can show it to us. Let's see if the build is done. What's going on? Okay. Yeah. I use wrong variable. Yeah, so this copy paste method is not that kind of perfect. So yeah, it's not A, it's message. So inside the message, get the value and put it in L is active. Okay, now it should work. And then we can jump to the calibration part. Have you tried to calibrate your car until now? Did you face any kind of problems? Okay, I have a question regarding the. Okay. After this, we will do the calibration part. Okay. So the build passed finally. Then let's repeat the process. So we have to go in our working directory, so documents, embedded platform, CMake build, target, develop, ZCC ARM, and robot car bin. Open a new Windows Explorer. This PC, Nucleo, drag and drop the new bin file, and booting up, wait for I'm alive. And I'm alive. And probably now our component will work because we didn't set any rule for the KL. So yeah, as you can see, periodics responded to us with the periodics test is now active. And now every 1 second, the run method is called and is printing this periodics test is running. Periodics test is running. Okay, then before we jump to the calibration part, any question until now? Okay. Position. Yeah, for the Nucleo, just pull the embedded repository, do the build process, and drag and drop the bin file to your board, and your Nucleo board is back to your original state. Now, according to the RPI, should work in the same manner. You have to, if you want to take some drastic measurement, delete the brain folder and pull it again. Maybe. Yeah, it's a drastic measure, but it works. Okay.
I agree.
We have pretty young participant.
That's the spirit. That's the only way you can win this competition. Starting from now. I'm joking. Youngster. Yeah. Okay. Then let me connect the Nucleo board back to my Raspberry Pi. Okay, and let's but before we jump to the calibration part, I have to ask you again, is everything clear? The debugging part, the flashing part, the building part, the new component part. All clear?
Yes.
Great. Huh, great. Then let's go to the calibration. Let's have the documentation of here. So yeah, but yeah, here is a very explained step-by-step guide. What do you have to do? But yeah. Also, before I do the calibration, what will be the change inside the embedded platform? So all the embedded platforms will have this speeding motor implementation file, and right now all of you, I think, have this method uncompleted. So there is nothing here. And what is going on? So right now, when you are setting the speed, you are not using a very efficient way to set the speed. You are using an interpolate method. Is not perfect, but it works. This is why you have to calibrate your car, especially your steering. Maybe the speed is working fine, but the steering has to be calibrated. So until you calibrate your car, the car will use the interpolate method. So what is the interpolate method? Basically is an interpolation. How is working? Well, 2 years ago, I have a lot of patients and I measured all the PAV value responsible for every speed. Yeah, until I reach the steering part, and then I say, hell no. And now we have an entire calibration process to do it in a more efficient way. So yeah, so the speeding should work perfectly until you calibrate it, but the steering absolutely not. This is why we have to calibrate the car. Now, what do we have to do? We have to connect to our car. Let me see if I'm still connected. I should be. So you have to connect to the car's Wi-Fi. Should be called BFMC demo car. The password is very secure, is super secure password. Then try to ping the car. Should reply, so the car is on. Also, if your car is on, the dashboard should work. So if you go to 192.168.50.1 port 4200, you should go. So yeah, the backend is working. Yeah, make sure you set the password for your dashboard. And here the password must be inside the process dashboard file. Let's set the key value to 30, so manual. So yeah, now you can see me. Not see me, the team, see me. Now let's start the calibration. Start calibration. So yeah, here is a gear icon. Press on it. Start calibration. And let's see. Lay out a straight line with a minimum area, minimum length of 3 meters. So yeah, make sure you have 3 square meters area available for the calibration part. Should be enough. Ensure there is at least 3. Oh yeah, to be calibrated. Let's hit next. So the calibration part will start with the left calibration. Position the vehicle as illustrated, ensure it's on a level surface with the wheels aligned straight. So the middle of the wheel, actually I have a better idea. So you draw the line, yes? The middle of the wheel is that nut. So make sure you put your nuts on the line. Now, yeah, let's start the calibration part. Start calibration. So yeah, next let's start with the left calibration. Type continue, and we will have, as I know, there will be a 5 degrees, 10 degrees, 15, 20, 25, and 27.2 to get the upper limits of the steering. So let's start with the 5 degrees. What will happen? Your car will start moving, so make sure you don't hit that button until your car is on the line, in the right position. Hit the button. After that, you have to measure these 3 different distances. Make sure you are measuring right. I mean, yeah, it's pretty straightforward. After that, insert your values over here. Yeah, the values are in millimeters, but I think there is no problem with that. Then we can rerun the 5 degrees runs. I don't know. There, maybe you want to do it again. You were not prepared, or you moved the car. I don't know. Just rerun it if you want. Then you have to submit the measurements. I will not submit any values, so we will not be able to see any plots, but this is normal. Then let's start the 10 degrees run. Okay, just put the values, submit. 15 degrees run, put the values. Okay, submit measurement. 20-degree run. Put the values, submit measurement. Oh, so it's a 23.2 degrees run. Okay. Okay, put the values and then submit. 25-degree runs. Why do we have this kind of value? So in the end, we have 23.2, 25, and there will be 27.2, because we are trying to get your upper steering limit. And as we know, the car is not able to pass the 27.2 degrees due to mechanical reason. Okay, then Also, if you want to add multiple times, I think Bogdan already explained it over here in the documentation. So you should be able to add, let's say you want to do it, you want to do it every 1 degree. Yeah, it's here. So yeah, all the steps that we are going to do it today are put it here. So if you want, as you can see, we have the 5 degree, 10 degree, 50 degree, 20 degree, and so on. If you want to put in every 1 degree, 1, 2, 3, 4, 5 until 30, you can do it. Just use this format and your car and your dashboard will respect it. Now back to our part. Let's admit these values. And here in this step, you have two decisions to make. You can hit continue if you want to stay on the left calibration part. So let's say you are not happy with your calibration process and you want to do it again, press continue and the left calibration part will start over. And if you are happy with your left calibration part, hit next. Then the calibration will go to the right calibration. Again, I will try to do it as fast as I can because it's pretty much the same. You put the car on the line, measure it, submit the measurements, and so on with the steps that are declared in the script. 50-degree run, 20-degree run, 23.2-degree run, 25-degree run. Okay, 27.2-degree run. Submit it. Now, again, if you're happy with your right calibration process, hit next. If you are not, hit continue to redo your right calibration. Next, the test run. Yeah, put the car on the left part. Next, what's going on? Oh yeah, we have to do it. Continue. So yeah, you're not able to pass the steps. If you don't complete all the steps, the calibration will tell you that, hey, this is not completed. So yeah, correctly, we will start the 0-degree run, and then you will be asked, hey, the car is straight or went to the left or right? Let's say to the right. Please recalibrate the vehicle. Oh my God, no. What have I done? Okay, now let's see. Oh, okay, let's try to do to put some values also here. Let me see that if this is still working. Okay, but yeah. Let's go straight. So yeah, your car is not went straight. You have to redo your calibration. Also, this calibration process is available and recommended after you already calibrated, because as much as you calibrate your car, as much as perfect will be. Hit next, continue, let's do it. -23-degree run, the 25-degree run, and the 27.2-degree run. And of course, let's go to the next step, the test run. Okay, so here is the trap. Let's say red pill or blue pill, straight. Everything is perfect. Now, what is here? Test run completed. I think we can go to the next step. Yeah, load plots. There is no plots because I didn't put any values. And also there is a backward calibration because your car will go upward, and in the end we have to calibrate the backward part. And let's do it. We will start with -10 centimeters per second. Respect the figure, measure it. As it showed, should go straight, as we told the calibration process that is going straight. Okay. Oh. And I think there would be a -50, yeah, -50 centimeters per second backward run. Submitted. Yeah, it's completed. So we are happy. We can hit next. Uploads, these are not available. And now we can save and download the calibration. So yeah, calibration files successfully generated. And yeah, if you have this kind of error, just hit keep because this line is not secured. We don't have a certificate for this Raspberry Pi connection. Okay, now that we have there will be a zip, but before I flash the calibration into the embedded platform, let me go back to this error. So I have a question regarding, I have the visualization plot, but when I click save, nothing. Okay, can you tell me what browser did you use for the calibration process? Maybe there is a browser issue because, so I don't know, we tried on Google Chrome, we try on Firefox Mozilla, and also on Microsoft Edge. So they are allowing you to download some things for not secure websites. I don't know if this is okay or not, but it's working. Maybe your browser is too tough when it comes to the security rules and is not allowing you to download. As you saw, also my browser told me that, hey, this is not a secure website. Are you sure you want to keep these downloaded files? Yes. Hi guys. Also, from those who already tried, maybe you can tell me, hey, I tried, I managed to calibrate the car and I used the Google Chrome browser. Yes, please.
Sorry, like I have answered you like into the chat. So like I use Chrome, and my friend and I have just the same problem. Like we have finishing like all the calibrate step, like but the last step in order to download and export the file, so we cannot do it anything. Like the screen is frozen, and we try to spam like the download button, but nothing happens. So that is my problem.
Okay. And have you tried to close the model and open it again, or is not working at all? It's totally freezed.
Like I think like the browser is freezing. Like it's don't reaction. It don't have any reaction when we click on the download. So we have setting up like everything that according to to the instruction. So I'm not quite sure. So do we have to like turn on the motor and set the battery mode or something to in order to calibrate it?
No, as you saw, I didn't did anything special. I just opened the dashboard and hit the gear icon and start calibration process. I don't know. Maybe you try to inspect the website. Maybe there is an error in the console, or you are not able also to inspect element the website.
No, like everything is working fine for us. Like we can control the car, like setting up like the run to the left, to the right, and going backwards. So everything is fine. Just like the problem in the final step of exporting the file, the calibrated file. So that is our only problem. So only in the last step. So yeah.
Okay, maybe you can try with another browser.
Okay. I will give it a try later. Okay.
We have the same problem. Is it possible to SSH into the Pi, because the file should be somewhere on the Pi, no?
Yeah, that's right. The file should be inside your Pi. So
Do you know where on the Pi it
yeah,
should
yeah,
be?
yeah. I know. Let's go to the brain repository. As I know, here we go. Be here should be inside source. Hmm. No, lengthy. No. Okay, so here are the templates. Here is the calibration. We're getting there.
I have a question. So like as you said, like the calibration file will be downloaded into the Pi, right? Not on our PC. So is that correct? Or
Both. As you can see, I have the zip file also here on my personal computer, and also should be inside the Pi.
so like we don't have like the file on our PC, but then we will check again in our Pi. But it would be nice if you can show us like where would it be like downloaded from the website?
Yeah, I will find. Just give me a moment. So yeah, mm, it should be. Or oh yeah, and let me connect to the Raspberry. Because I think I'm not able to see it in the Git repository. Okay. In the documents, brain, and let's see. So yeah, should be in source, and that's for sure. Oh yeah, metadata. No, not metadata. Not. Oh, hold on. There is a calibration directory.
We just found it. It's in documents, brain calibration templates.
Oh yeah. Not really, because in templates are only the templates. Should be calibration that there should be a source file. I don't know why it's there. That's interesting. Or maybe let's go inside the templates and let's open them. Let's open the nano speeding motor. No, no, it's just the template without the, yeah, it's just the template without the, maybe, let's invite the owner. Here we go. This should, okay. Okay, but we will come back to this part. So yeah, should be here. So inside brain calibration, there should be a source file. I don't know if you have your Raspberry Pi near to you, but please check it. Maybe in your case it's there, because right now I'm using a jumping host to connect to the Raspberry Pi, so I can sit in the meeting with you, sharing while I'm working on the Raspberry Pi. So
sorry,
yeah.
like, can you tell me again, like, the directory of where the calibration file can be downloaded on the Pi?
Yeah, so try to go over here. Let me paste it. I will paste it in the chat.
Yeah.
Oh, yeah, I know why. Because in my case, I put zeros on the measurements. So there is no calibration in my case. but go check if you have inside the brain calibration directory a source directory. And until
on
then,
the Raspberry Pi, right? On the Raspberry Pi.
yeah, on the Raspberry Pi. Raspberry Pi documents. Okay. Until then, let's take some questions. Yeah, bro, he loves these meetings. That's great. That's great. Why is the Raspberry Pi hotspot also intermittent? Is there a way to make the Raspberry Pi turn on? Why is that? What do you mean intermittent? Should be always on. So, or are you having some problems like your PC is disconnecting from the Raspberry Pi hotspot? I have a workaround for that. Go to your view network connection. View network connections. Go here. Wi-Fi. Right click. Should be status, wireless properties, and yeah, I am not able to do it on this PC, but make sure you check connect automatically when this network is in range. Uncheck, look for other wireless network, and check the connect even if the network is not broadcasting. And then you should be connected all the time to your Raspberry Pi. Now, hello, we did the calibration finished after seeing the plots, but we cannot download the files in the end. Can we manually create it? Johnny, please check the path that I put in the chat. Maybe you can find it over there. So it's inside documents, brain, calibration, source. And there should be your files. Because you don't say you have to see the network is not reachable, you create a hotspot. Yeah. Yes. We don't connect the server. Is there a way to fix it? Try what I told you. Are you talking about hotspot brain connect? I understand. It's very unstable. Yeah, I know. Very unstable. You mean that your PC is disconnecting from the hotspot due the okay. Yes, I have some problems. Okay. Hotspot. Raj already responded. So I have to spam the save and download button. I use Chrome. Chrome address. I see the problem using global, right? Yes, it is. Okay. I will try to shows up in robot. Okay, I think here.
Yeah, so I can cover this one. Ethernet in parallel with hotspot won't work because the Raspberry only has a single interface. So if you have hotspot already activated and you plug in the Ethernet cable, it will be discarded and it won't work. So just stop one or another. Yeah, you can just uninstall our Wi-Fi fallback service and then use the Ethernet. Yeah. This is going to work. Yeah, or otherwise, if you can want to simplify your life, just use the hotspot just to set your Wi-Fi network, then the Raspberry will connect automatically to that network. Then you can SSH and FTP into the Raspberry, and it will be easy life for you. In Ubuntu, you can do everything. In the File Explorer, in Windows, you need WinSHP or something, but still, but I think also in Windows, you can do it in File Explorer. So yeah, it's easy life for you, but yeah, okay. Probably keep going.
Yeah.
On the SSH for the calibration file, and in the calibration folder, we only have the templates directory as a subdirectory from the documents brain calibration. Even after we finished, we completed everything, but there's still only the templates.
Okay, let us check this, and we'll do a complete calibration to see if it's there. And if the files are not there, we'll just modify it so that the script saves them there.
All right, thank you.
Because the complete calibration will take some time, and yeah, it's not productive to do it now, but yeah, we will come back to you with this.
Yeah, okay, perfect. Thank you.
Thank you as well.
Sorry, I also want to ask, like, if there are some change, like, do you also like modify like the document website so that like we can follow again the calibration step? So
If we do changes, we just push the code on the brain. So that's why in the documentation, let's say, we say to pull the entire code from our brain, because this way you will see that there are modifications and you can just pull what we modified. So yeah, if we do it, you will see the pushes in GitHub.
okay, yeah, thank you.
You're welcome. But we will also post on the forum when we fix this. But I also have a question regarding this. Do you understand what this calibration is doing? Is it clear for you? Yes? No?
Yes,
Maybe?
pretty clear for us too, at least.
Okay. And none of you managed to successfully do a calibration? Is there someone that did it? Okay. And I guess there are 3 teams that tried it. I don't know. As for the comments, I see 3 people talking about the calibration errors. So are there more that tried?
Not successful in calibration. The calibration data are stored on Raspberry Pi. Not yet, but we are positive. Yeah. And I guess all of you try with real values, not like me with zeros. Actually, let's Patel.
Are we allowed? So if we are trying to upgrade to Jetson Nano Orin, so are we allowed to use a UPS, a dedicated UPS for the Jetson?
What do you mean by dedicated UPS? Not familiar with
So
the term.
we don't want to. So on the power board, we are thinking instead of using the power board for the Jetson Nano, can we use a separate UPS module for the Orin just to separately power the Orin?
Yeah, and you can. I mean, yeah, sure. You can do any modification. Just post it on the forum.
Okay, sure. Thank you.
You're welcome.
Okay. Then let's try it again. Let's calibrate the car again. This time I will put some values. Okay, so let's put some random values. Maybe it will work. Okay, submit the measurement. Because I don't. Okay. I hope this is working. So, there's a degree run. And of course, those are some random values. I don't know how the plots will look like, but I hope we will see something and we will see the generated files. Okay. 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 No. So yeah, I hit left, continue instead of next. But I'm going to do it again, but we are not, I don't want to keep you until midnight. So this is because it's already late for most of you and for us included. So I think I will stop the share screen now. In all this time, the presentation screen is not visible. And did you guys can see it or not? Okay. So we are going to do it off the record, and if everything works, we'll come back to it that hey, everything is working, and maybe also Bogdan will help you on the forum. Maybe some of you can create a new post on the technical questions, a new topic actually on the under technical question section with the calibration error, and Bogdan will help you debug the problem. Oh my God, it's 1 p.m., 1 a.m. in Vietnam. Actually, I see that Bogdan is here with us. Maybe Bogdan can share his screen for a demonstration.
Yeah. Hi everyone. So let me know. Can you see my screen right now?
Yes, we can.
Okay. I have some let's say dummy data already inside the code, so I won't have to literally do the whole calibration. So I already have the steps completed. So I can go on with everything. So basically, as I think Radu showed you before, you will have each step and you will have to take some measurements and submit them. After you finish with the left calibration, you can go on with the right. And of course, after you'll have a test run where you can test the car to see if everything is properly calibrated. So if the car is going to go straight, everything should be fine. If not, I think something went wrong. So you can either continue with the calibration procedure and redo another one after, or you can start over again. So after the test run is done, you can see the zero offset spline visualization. So in this plot, hopefully you can see it properly. Wait, can you see my screen right now? Because I just like full screened the VM.
Yes, we can see it.
Okay, so basically what is here, the car most likely is not going to go straight by default. So here shows you like the true zero. So the car to go straight with the current calibration that's provided by default, you have to go with minus 4.36 degrees. So this is what this graph is showing. So it's trying to calculate the actual 0 degree steering by using the old algorithm, let's say like this. So you can check this out. It's not something that's, I don't know, going to help you by any means, but you can say, but what was the deviation of the car, let's say like that. After that, there will be a backward calibration. You're going to do that only because you calibrated the car on the left and right side, and by doing that, we also calibrated the speed, but we only calibrated the speed going forward. Well, now we need to do that going backwards. So there will be like, I don't know, 3, 5, something like that runs, but there will be like in a straight line, easy to do. I won't go into them because those are going to modify my values that I already have put it inside the code. And after everything is done, you can go and plot everything. So here is the speed calibration. And as you can see, the points and the PVM and everything. And here is the steering calibration. So you will have max right and max left. So as you can see, here are some points that are outside, but those are without the 0 correction. This is why those points are here. And after everything, you can check this out and see if you like the graph. If not, you can redo everything. You can save and download. And as you can see, yeah, here everything is downloaded. And if the download is not working for you, what you can try to do is to go inside the brain, go inside calibration. There will be 2 folders right now. So a template one and a source one. We're going to use the source one. And there will find the files for the calibration. I've seen on the forum, some of you guys said that the download is not working. I don't know if it's because of the browser or not. Maybe try to use Google Chrome or Firefox. That might help. If not, check the console. There might be some, I don't know, some error, and you can give that to me, and I will try to fix everything as fast as possible.
Okay, guys. So Bogdan showed to you. If you have any problem or question, put it on the forum. This is it for today. It's a wrap. So if you don't have any other questions, we will and I hope you have very excited and very Happy holidays and see you next year.
Merry Christmas.
Merry Christmas.
Happy holidays.
Happy holidays.